See, now the topic is parasympatholytics. See, when it comes to the parasympatholytics, also we can call as a anticholinergic agents. Also we can call it anticholinergic agent or antimuscarinic agent. So again, this can be classified into antimuscarinic. See, because of two receptors are there. One is muscarinic receptor, another one is nicotinic receptor. The drugs which will act on the muscarinic receptor we can call as anti-muscarinic agent. The drugs which will act on the nicotinic receptor we can call as anti-nicotinic agents. Again, this can be classified into anti-nicotinic agents can be classified into ganglionic blocker, that is NN blockers, and neuromuscular blockers, NM blockers. Next, drugs classification. When it comes to the drugs classification, antimuscarinic agents or anticholinergic drugs, that is natural alkaloids. When it comes to the natural alkaloids, the first drug is atropine, atropine. Next, L-isomers means levorotatory drugs, that is 𝘿𝙬𝙎𝘾𝙐𝙎, 𝘿𝙬𝙎𝘾 also we can call it as scopolamine. Next, 𝘿-scopolamine also we can call it as iosine. Next comes to the semi-synthetic derivatives. When comes to the semi-synthetic derivatives, first one is mydriatic. Okay, it will dilate the pupil. Example is omotropin, cyclopentolate, tropicamide. Next one is COPD and asthma. The drugs can be used in COPD and asthma, that is ipratropium bromide and tiotropium bromide. Next one is peptic ulcers. The drugs which can be used in peptic ulcer, that is pyrinapine, telenapine, clidinum and propanthelin. Next comes to the antispasmodic drug. Example is dicyclomine, valenthamate, flavoxate, oxybutynine, tolterodine. Next, derifenacin, drotavirin. Next, Parkinson's. The drugs can be used in Parkinson disease, that is benzohexol, benzatropine, bipyridine, procyclidine. Next, last one, that is pre-anesthetic agent, that is glycopyrrolate. Next comes to the actions of atropine. When comes to the actions of atropine, it will reduces the secretion of exocrine glands. Next comes to the action on GAT. So it will reduces the tone, okay, followed by it will reduces the motility of gut, thereby relieves the spasm, any muscle cramps that can be relieved. Next, increases sphincter tone. So this is the sphincter will be located here, increases the sphincter tone, hence constipation will be there. Means the whatever the food is there, that can be struck here only, because of decreased movement of intestine. So hence antimuscarinic drugs should be contraindicated in case of constipation. Next comes to the urinary system. Okay, decreases tone of detrusor muscle. So decreases tone of detrusor muscle. Detrusor muscle nothing but this muscle we can call as a detrusor muscle. Okay, next sphincter will be there. So increases the tone of trigone and sphincter. See here, sphincter is there, that sphincter that can be contracted like this. Okay, because of this contraction, urine can be retained here only. Urine will be stay in the urinary bladder, it may not flow. So hence, because of this urinary retention, these drugs, antimuscarinic drugs, should be contraindicated in benign prostate BPH, nothing but benign prostate hyperplasia. Next is action on a respiratory system. So it will relaxes bronchial smooth muscles. Hence we can use these drugs. We can use these drugs in case of asthmatic patient. Next action is on eye. So it will causes passive mydriasis, cycloplegia and loss of light reflex. Next action on cardiovascular system, that is on heart. See, initially it will causes atropine, initially it will causes bradycardia, nothing but a reduced heart rate with low doses. After some time it will causes tachycardia. Hence we should contraindicate this antimuscarinic drugs in case of tachycardia condition. Next action is on central nervous system. So it will controls the tremor and rigidity of the Parkinsonism. Hence we can use these drugs in Parkinsonism. So in Parkinson's we can use. Next one is in asthma patient also we can use these drugs. So next comes to the atropine. See, we people already know anticholinergic drugs. Anticholinergic drugs that will decreases the all secretions. All secretion nothing but salivation, lacrimation, urination also get reduced, defecation also reduced, digestion is also get reduced. See, atropine is contraindicated in children due to the risk of hyperthermia, nothing but decreased sweating. See, it will reduces the secretions, nothing but even it will reduces the sweating also. Hence, this should be contraindicated in children due to the hyperthermia effect. See, atropine can be used as a drug of choice for the organophosphate and carbamate poisoning. We have already discussed in the last class. In the organophosphate poisoning and carbamate poisoning, we can use atropine as an antidote. And also drug of choice for the mushroom poisoning due to 𝙂𝙂𝙎𝙬 species. So this 𝙂𝙂𝙎𝙬 species also it will causes a poisoning effect. For that poisoning also we can use the atropine as an antidote. See, next comes to the medicinal chemistry of anticholinergic drugs. One is atropine. The first one is atropine. Atropine, it is a racemic mixture. What is that racemic mixture? Nothing but it is a mixture of dextro L-levorotatory iocyamine will be there. Also we can call it as scopolamine. Upon hydrolysis of this atropine, it will give tropine plus tropic acid. Next, atropine is a racemic mixture of iosine. Scopolamine, upon hydrolysis, it will give scopine plus tropic acid. So like that it is, means hydrolytic products these are. Next comes to the atropine. So this is the atropine, this is a racemic alkaloid. So this is the structure of atropine. This bond we can call as a wavy bond. Wavy bond, it indicates the direction is unknown. So the CH2OH methanol functional group, the methanol substituent direction is unknown, means sometime it will be above the plane, sometime it will be above the plane, sometime it will be below the plane. Hence see, in case of D isomer, the CH2OH is above the plane. In case of L isomer, the CH2OH is below the plane. Hence we are writing on wavy bond. It is non-directional. So this is a atropine is a racemic mixture. Next, iocyamine L form. See, this is a iocyamine. See, this iocyamine, this CH2OH group is below the plane because it is on the broken wedge. It is on the broken wedge. It is the below the plane. Okay. Next, scopolamine also we can call as a 𝘂𝙎𝙎𝙎𝙎𝙬. This is also L form. So what is the difference between 𝘎𝙎𝙎𝙎 and 𝘂𝙎𝙎𝙎𝙎? Nothing but there is a presence of epoxy group will be there, but here no epoxy group will be there. So that is a major difference. Hence we also see 𝘎𝙎𝙎𝙎 also we can call as scopolamine. So the CH2OH group is, everything is same, the structure up to here it is same, but only the presence of epoxy bond it will differs. So this is the chemistry of atropine, hyoscyamine, scopolamine. Next comes to the atropine structure. So this is the structure of atropine. Okay, when we are identifying the structure of atropine, what is there? First we need to identify the functional group for writing the IUPAC nomenclature. What is there? Ester group is there, followed by alcohol group is there. Next, amine group is there. So among these different groups, ester group will get first priority. So we need to give the numbering from the ester group. 1, 2, 3. Okay, after that, so this is a bicyclic compound. In the atropine, this is a bicyclic compound. For the bicyclic compound, the nomenclature and numbering is completely differs. Now we can observe, so it is a bicyclic compound. How we can identify means, these are the bridge head atoms. These are the bridge head atoms. See, if I have started my journey from here, then going like this here, then came ended here. So this is the one ring. Next, second portion is like that I am going nitrogen, it will become ended. So two rings will be there, hence we can call it a bicyclic compound. So for the bicyclic compounds, this carbon is tertiary carbon. So the numbering always starts with tertiary carbon, because the tertiary carbon atom is more reactive. So the numbering is 1, 2, 3. So here also this carbon is there, CH2 group is there. That's why we are giving the numbering 4. Next 5, 7. Once the ending of 7, again we need to go to the third bridge. See here 3 bridges are there. See, these are the 2 bridge head atoms. So this is the, so this is the one bridge. Okay, this is the second bridge, this is the third bridge. So 1, 2, 3, 3 bridges are there. When comes to these 3 bridges, first bridge it containing 3 atoms. See, the first bridge that containing 3 atoms. One, we cannot consider this head atoms for the bridging. See, 1, 2, 3 atoms are there. Second bridge, sorry, the second bridge is this one. The second bridge it containing 1, 2 atom. The third bridge it is containing only 1 atom. So like this, the first bridge it containing 3 atoms. We need to give more priority. That's why numbering we need to give 1, 2, 3 like this. After that we can go for the fifth one. This second bridge it is containing only 2 atoms. That's why it is 2 atoms containing second bridge. The third bridge it is containing 1 atom. So like this it is. Next, when comes to the IUPAC nomenclature, we need to write IUPAC nomenclature from the back side. See, propanoate, see 3 carbon, 1, 2, 3 carbon containing ester group we can call as a propanoate. Next comes to the 2-phenyl. Second position, it contains phenyl group. Okay. Third position, the third carbon that is containing hydroxy group. The third carbon that is containing hydroxy group. If any group or any substituent that is present on the oxygen hetero atom, okay, we can consider this as a prefix. Prefix means we need to write in the starting. We need to write as a prefix. Then how can we write this prefix means, see 8-methyl. At 8th position, what is there? Substituent, that is methyl group is there. Next at 8th position, what is there? Aza group is there, means nitrogen is there, 8 aza. Bicyclo, the compound is bicyclic. One of the bridge, it is containing 3 atoms, that is 1 2 3 atoms. Second bridge, that is containing 2 atoms, 1 2 atoms. The third bridge, that is containing 1 atom. Like that, 3.2.1 oct, total number of atoms. Total number of atoms in the bicyclic compound is 8. That's why oct. The third position, it is get substituted here. The third position is substituted to the ester group, hence 3-yle. 3-hydroxy 2-phenyl propanoate. So this is a IUPAC nomenclature of atropine along with structure and numbering. Next comes to the homotropin. So this is the structure of homotropin. When comes to the structure of homotropin, it containing, see in the name only it is containing Ma, nothing but mandelic acid. See, Ma nothing but mandelic acid. What is that mandelic acid? Nothing but this structure. So this structure we can call as mandelic acid. The hydrogen is replaced with this bicyclic compound. Okay, that's why the name homotropin, mandelic acid containing drug, that is homotropin. If sometime in the GPAT they might be asked, what is the basic nucleus present in the homotropin? Basic nucleus. What is that basic nucleus? Is mandelic acid. Next comes to the ipratropium bromide and tiotropium bromide. So this is a ipratropium bromide. This is a structure of ipratropium bromide. See, what is the name? How it is get derived means ipra, nothing but isopropyl. Isopropyl group is there. Okay. Next, atropine is there. This is a basic structure of atropine. In that atropine, what is there? Isopropyl group is there. Hence, we are writing as a ipratropium. See, IUM indicates, I have told IUM or onium, it indicates positive charge. It indicates positive charge. See, positive charge is there on nitrogen. Next, first we need to identify the functional groups. Ester group is there, alcohol, okay, quaternary ammonium group is there. Next, when comes to the IUPAC nomenclature, first the numbering it will be started with ester group 3, like that. After that, we people just now discussed for the atropine. See, the numbering is head atoms first, 8. So now the IUPAC nomenclature is propanoate. See, now the IUPAC nomenclature is propanoate. Okay, 3 carbon containing ester we can call it a propanoate, followed by phenyl group is there. So second position phenyl group, third position hydroxy group, 2 phenyl, 3 hydroxy group is completed. Next, whatever the things that is located on oxygen atom we can consider as a prefix. When comes to this prefix, on 8th position what is there? Methyl group is there, substituent, hence 8 methyl. On 8th position only what is there? 1 2. So 1 methyl, on one group, on first position, what is there? Methyl, 1 methyl ethyl, 2 carbon containing ethyl, 8 aja. 8 position it containing nitrogen, hence azonia. Azonia nothing but onium group. Positive charge containing nitrogen we can call it azonia. Next bicyclo, it is a bicyclic compound. One of the bridge it containing 1, 2, 3 atoms. So these are the bridge hedges, 3 atoms. One bridge it containing 3 atoms, second bridge it containing 2 atoms, that is 2. The middle bridge it is containing 1 atom. So 3 to 1 oct 8, total 8 atoms are there. Hence oct 3-yle, the third position is get substituted to the ester group. So this is about the ipratropium bromide. Next comes to the tiotropium bromide. See this tiotropium, how the name it is derived means it containing thiol. It containing thiol. See this group we can call as a thiol. This group is thiol. Because of the thiol group we can call as a tiotropium. So this is a structure and numbering and IUPAC nomenclature. Okay. See what is there? Nonane. Nonane means 9 carbon containing. Nonane bromide I have told. If it is a anion will be present means we need to write at the end. That is bromide. Nonane means 9 atom containing bicyclic compound. 3. See 1, 2, 3. One bridge it is containing 3. Another bridge also it is containing 3 atoms. Okay, 3 atoms. Next middle bridge it containing 1 atom. Middle bridge it is containing 1 atom. But the second bridge, the second and fourth position are get connected. The second and fourth position are get connected, hence 0. See no atom is there between 2 and 4. That's why 0, 2 to 4. 0, 2 to 4. Nothing but 2 is connected to the 4. Like that the meaning it is. Next nonane bromide. Okay. So next third position what is there? 3-oxa. See third position it is 3-oxa. Ninth position what is there? Azonia. Azonia nothing but nitrogen with positive charge. Tricyclo. So it is a tricyclic compound. It is a tricyclic compound. It is a tricyclic compound. Next one is tricyclic compound. At ninth position what is there? 2 methyl groups are there. 2 methyl groups are there. That is 9,9 dimethyl. So this is the IUPAC nomenclature. Now here what is there? At 7th position. At 7th position what is there? Hydroxy. Okay. Hydroxy group is there. 2 thioenyl acetyl means second position. 1, 2 second position. At second position what is there? Thioenyl group is there. That is 1, 2. Thioenyl group is there. This is the acetyl group. We can call it acetyl oxy group is there. Nothing but here the oxygen it is. So like that tiotropium bromide, the structure, numbering and IUPAC nomenclature. See next comes to the when comes to the cholinergic side effects. See we people already know cholinergic nothing but parasympathetic nervous system. When parasympathetic nervous system is there, all secretions might be get increased. The mnemonic is SLUD. Yes, nothing but salivation is get increased in case of parasympathetic activation of parasympathetic nervous system. Lacrimation, lacrimal fluid in eye is get increased. Urination will be there. Digestion will be there. Along with defecation will be there. These are the cholinergic side effects. When comes to the anticholinergic side effects, see anticholinergic nothing but we are giving the antagonistic drug. If you are giving antagonistic drugs, what will happen? Reduced salivation. salivation is get decreased salivation, it may leads to the dryness of mouth. Next, decreased lacrimation. If lacrimation is get decreased in case of eye, it may leads to the blurred vision, we cannot see any objects properly. Next, decreased urination. Okay, nothing but urinary retention, decreased digestion, improper digestion will be there. Next, decreased defecation, we can call as a constipation. So dryness of mouth, blurred vision, urinary retention and constipation, these are the side effects of anticholinergic drugs. So with this we have completed sympathomimetics and sympatholytic drugs.